Okay. Tonight's chapter is about ANOVA, analysis of variance. Anyone experienced with an ANOVA earlier? Anybody? No one?
No, Dr. Kim.
Okay, good. When I was at one of the Minnesota State University, when I worked there, always when I teach statistics, not here at Marywood, I don't teach statistics, but I include this ANOVA part, but many, even you took statistics earlier, many instructors didn't cover this ANOVA test. After I left that Minnesota State University, about 1 year later, one of the former my students emailed me and then asked me, email said, did we cover ANOVA? So I replied, yes, we did. And then I sent the syllabus and lecture note and so on. The student asked because the student tried to enter a graduate school, and then graduate school, business school. That school was the U of M, University of Minnesota. The school asked the student if the student took statistics and then the statistics class covered this ANOVA, then the school waived the student taking the statistics at the graduate level, but the instructor didn't cover ANOVA, then the student should have taken statistics again. So I covered this part. So the student, I saved the student money and time. So anyway, many statistics class instructor don't cover this. Okay. Analysis of variance, short name is ANOVA. This one is the simultaneous comparison of several population means. You know, we covered the hypothesis test earlier. So if we have one sample, using sample and then compare with the population and then test. And then if we have two samples, then we use the two sample hypothesis test. But if we have 3 or more samples, then we cannot use the hypothesis test because the hypothesis test only one sample and two samples. If we have 3 or more samples, then compare 3 or more samples, then we use this ANOVA. So for the ANOVA test, using F distribution, last time, you know, when we covered regression analysis and then test, global test, if we made the equation right or not, then using F test, and then if it is significant, then we say at least one X variable useful to predict Y variable. This ANOVA test the same using the F distribution for the ANOVA test. So a little bit about F distribution. It was named to honor Sir Ronald Fisher. So the last name, initial F. So using this one, F distribution. One of the founders of modern day statistics. And then used to test whether it said 2 samples, but then 3 or more samples. And then the populations must follow a normal distribution, and the data must be at least interval scale. You know, interval scale means if you took statistics, and then if you remember, then the numeric data, types of numeric data, interval or racial. Interval data, if there is no true zero, then we call that interval scale data. Like a length from 0 to a certain number, that is an interval scale. If we, measure the class size, especially ladies in class, the size is 1, 2, 3, 4, 5, like that, right? That case, there is no zero size, right? Usually 1, 2, 3, 4, 5. In that case, if there is no true zero, then we call that racial scale data. Anyway, so if we have numeric data, then using this 3 or more sample. And then F distribution looks like this. Always positive scale from 0 to certain number. And then last time when we did the regression analysis, then using F distribution, then we need 2 degree of freedom. So first one, DF1, DF2. Another name is the degree of freedom in the numerator and the degree of freedom in the denominator. So first one is the numerator and then the denominator, second one. But anyway, just in the DF1 and DF2. And then based on where is critical value, then right side, the F statistics, then reject, do not reject, so on. One factor analysis of variance. There is another one, 2-factor analysis of variance, but we use only one factor. If we have only one variable, but multiple groups of sample. So always for the like hypothesis test, whatever test, we need 2 values, test statistic and critical value. For F test statistic, F equals MSA divided by MSW. MSA is the mean square among groups, and MSW is the mean square within groups. MSA is SSA divided by C minus 1. C is number of groups, that means the number of sample. If there are 3 samples, then C is 3, 4, 4, and so on. Then SSA is sum of square among groups. Looks like this, but don't worry about this. And then MSW that is denominator of F F test statistic. SSW is the sum of square within groups. And then N is total number of sample. So if it's like that, if there are 3 samples, the number of sample is 3, and then each sample has 5 members, then 5 times 3 is 15. So this is kind of total sample size. And then minus how many sample. So this one is C minus 1 is DF1, and N minus C is DF2. When we find the critical value from the F distribution. So hypothesis for this ANOVA test, null hypothesis, mu1 equals mu2 up to how many, the number of the sample. So if we have 3 samples, then mean 1, sample 1, mean 2, mean 3 equals, and then not all means are equal, alternative hypothesis. And then using C minus 1 DF1 and then N minus C as DF2, find the critical value and then compare. And then if F test statistic is greater than critical value, then we reject the null hypothesis. That means at least one mean of sample different from others. Looks like this. Okay, we have an example data, and then using a 0.05 alpha significance level, then test. If this sample indicate actual difference in the mean, there are 4 samples. Station 1, 2, 3, 4. It's like that. There are 4 production station or retail store, whatever. Then sales for production rate. Compare those stations or stores. So this one sample, the number of sample is 4. Then sample size of each one is 5. So using this data. So bring up the data from this moment. The data set is on Moodle. So if you can do, let's do it together. So in this ANOVA and chi-square data. So I will bring up that data. When you are ready, then let me know. Then let's do it together.
I'm ready.
Okay. For our research, if you compare the daily average positive cases using several states, like in New York, New Jersey, Pennsylvania, Connecticut, and so on like that. Then if samples, the number of sample like states, 3 or more, and then compare those states daily case, then you may use this ANOVA test. Because state by state use different rule, like a face mask rule regulation. Then maybe they like a increasing rate or different. So compare those difference, or if they are the same like that, then you may use this ANOVA test. Okay, let's do it. So using whatever, some of you had the difficulty to install a Megastat or the data analysis, whatever. But I will let's use now Megastat. Oops, where is now? Okay. When you click on Megastat, by the way, do you have a Megastat?
Yes, I do.
Okay. How about others?
I do, Dr. Kim.
Okay.
I do not, Dr. Kim.
I do not either.
Why?
I've been using Google applications, and I've been trying to keep off from buying Microsoft Office until someone pays it for me, like a job. So yeah.
Okay. If you cannot, then just watch. I don't know if Google you can use other tool like data analysis or not. Then if you can find an ANOVA test, then using whatever tools ANOVA test. Here, analysis of variance. This is an ANOVA test. So click that one, and then because these numbers variable is number of cartons packed. So only one variable. So compare one variable. So this is one factor. So if you have data like 2 factors, like the number of packed, and then what can be other variable, number of packed, and then number of shipping and so on like that, then you may use 2-factor ANOVA test. But this one is only 1 factor. So click 1 factor. Then this one ask input range. Just simply specify input range. And then usually, alpha is 0.05. So using just 0.05, then click OK. The output, we call this ANOVA table. And then I said now we need 2 value for test. So F value is this one, test the statistic. So from the formula, F tested statistic equals MSA divided by MSW. And then MSA is SSA divided by C minus 1. And then SSW divided by N minus C. So from ANOVA table, this is MSA Then this is MSW. And then MSA is SSA divided by C minus 1. So C is the number of the sample. So 4 minus 1 is 3. So DF1. So MSA equals SSA divided by C minus 1. And then MSW equals SSW divided by N minus C. N is 20 minus C 4 equals 16. And then F equals MSA divided by MSW. So F test statistic is 4.12. And then we need a critical value. So using this megastat again, like we did, yes?
Yeah, but N here is 5. Why is N 5?
N is sample size. Go back to the data set. And so 1, 2, 3, 4, 5.
Okay, got it. Thanks.
And then we need a critical value. So critical value, like we did last time in megastat probability, and then F distribution. And then alpha is 0.05, DF1 is 3. So you can type in 3 there or just click the cell. Then DF2 is 16. And then click OK. Okay, critical value is 3.24. And then, F statistic, test statistic is now 4.12. So this is outside somewhere here. So test result is reject the null hypothesis. So that means one or more sample is different from others. Then if we use, let me use data analysis, Excel data analysis for the ANOVA test. ANOVA here, single, then OK, then input range, and column, data, and then label. And let me see, somewhere here. If we use this one, just the basic Excel data analysis, then give it the same ANOVA table. The F test statistic is the same, 4.12. And then you can find the F, I'm not sure this time, but you can use the function like I don't remember, F distribution, this one, and then degree of freedom 1, first one is 3, and 2 is 16. And this one cumulative or not, we may one, oops, not that one. 16 and 1. What the?
The first one is the value of X, the X variable. The second one is the DF1, and the third one is DF2.
Just a moment, cumulative or not, 0. I don't remember what should I true or T. I don't know. So you can use I will figure out later, but you can use the Excel function to find the critical value. But anyway, you know, using this basic data analysis, then you can get F statistics, and then using whatever function, then you can get critical value. Then you can say it is reject or do not reject. But you don't know which sample is different from others. But if you use this megastat, then this one indicate.
Dr. Kim,
Yes.
if you could go back to the example page. Yes.
Mm-hmm.
So you use the function F distribution.
Mm-hmm.
In the arguments, I could see that the first input value has to be the X value. If you type that again, yeah. It has
F
4,
distribution.
yeah.
Maybe
Yeah, just go
I
to
don't
the,
remember.
no, just do F distribution again. Yeah, and then
And
if you
degree
see
of
there
freedom,
are
X value.
4,
What is
yeah.
X value is? What is X value?
I don't know that. But it requires 4 arguments: X value, 2 degrees of freedom,
Yeah.
and then cumulative. So I think that was missing.
What is X value? Maybe 20. Then let's try one time. Then later, if I then later I will figure out what
Okay.
the X value we should now type in. Then 3, 16, and if it is usually you that is true. .999. What is that?
That's because of the X
The-
value, because we just took a random value.
Yeah. I'm not sure because I didn't use this function. But anyway, I will figure out. Okay, so go back to this. Then here, the dark vivid yellow, station 2 and then station 4 are way different. And then station 1 and station 4, little bit different. Station 2 and station 3, a little bit different. So based on this ANOVA test, not all stations number different. Then based on this megastat output, we can see station 2 and station 4 different. Station 1 and station 4 different. And then others similar. So using this ANOVA test, we can say we can test if they are the same or not, like that. And then based on this output, we can say which is sample and then which is sample different, which is sample the same, and so on. So this is the ANOVA test. And then for you, I made practice problem. Okay, looks like this, the first one. Okay, I will, let's take a quick break. Now it's 6:50. So I will be back 7, a 10-minute break. So just if you want just to try, then when I come back, then I will go over this one. Okay. I'm back. Okay. Practice problem. MBA director examined GMAT scores for the first 10 MBA applicants, assumed to be a random sample of early applicants for 4 academic quarters. So the number of samples is 4 for this one. So because the number of samples is 4, 3 or more, so using an ANOVA test and at alpha equals 0.05 to the mean GMAT scores for early applicant differ by quarters. So using data, this one, the same, I will use Megastat. One factor, because this variable is GMAT score. So one factor, and specify, okay. So ANOVA table, F test statistic is 0.09. Then we need critical value. So DF1 is 3, DF2 36, DF1 3, DF2 is 36. And then alpha is 0.05, given alpha is 0.05. Then click OK. So critical value is 2.87, but the F statistic is 0.09, so way inside, somewhere here. So test result is do not reject null hypothesis. So we can say 4 quarters GMAT score of applicants are not different. So I upload the practice problem answer. Looks like this. So hypothesis H0, H1, because there are 4 samples, quarter 1 to 4. So mean of quarter 1, mean of 2, mean of 3, mean of 4 equals the same. And then alternative hypothesis, not all means are equal. And the alpha is 0.05. Test statistic is 0.09 from the output. And then critical value 2.87. DF1 is 3 when DF1 3 and DF2 is 36. So critical value here, and then test the statistic inside. So decision is do not reject the null hypothesis. So conclusion based on this test, the mean GMAT scores for early applicant does not differ by quarter. So if you have like an earlier example, the state by state, the case data, then like 4 states, then compare. Then if the test result is do not reject null hypothesis, then we can say those states daily positive case are not different like this. Okay. So based on what kind of your data analyze, then you can use the hypothesis test, regression analysis, and then test each variable. And then you can use this ANOVA test for your research. So many cases we use those tool, statistical technique and tool for research if you have data. Okay, do you have any question? Okay. Then, next one. This one shows the result. Next one is chi-square test. So far, hypothesis test, ANOVA test, and also regression analysis. Using sample, and then we test the population. So we call that parametric test because we have population data, test the population using sample and population. But then chi-square test, one of the non-parametric test without population data. Just to use sample data and then just to compare samples, and then based on the sample data, we can get test results. So without population, we can use this one. So non-parametric test, and then others are parametric test. Chi-square test is similar to the ANOVA test. If we have multiple data, then compare, then we can use this chi-square. The researcher may believe there's no relationship between X and Y, but doesn't want to use linear regression, and then use chi-square, just using sample without population. Then there are outliers or abnormalities that prevent us from assuming that data came from normal population. That case, we use chi-square, and then the researcher has numerical data for one variable, but not the other. So one variable, this is like a one factor ANOVA test. When we say a contingency table, contingency table, row and column data looks like this. Variable 1 and then variable 2, then indicate 2 variables in one table. We call this the contingency table. So this chi-square test use this contingency table. chi-square test, hypothesis test, similar. So we need a hypothesis H0. Variable A is independent from variable B, and H1 alternative hypothesis. Variable A is not independent of the variables. So from example, not here. Nationality of the website, and then location of disclaimers. So using two variables. Let me see. Like in team 2, the data, like an age data, and then disease data. Then if they have something relationship or not, so that case we can use this chi-square test. So go back. So use the chi-square test for independence to this hypothesis. This one is non-parametric test because there is no population data. And then we need kind of frequency. So observed frequency and then expected frequency from the, I will tell about that with the example. And then similar to F-test, using a chi-square distribution, then we need a degree of freedom like this, R minus 1, C minus 1. So number of wall, number of, number of variable A's, and then number of variable B. So row and column minus 1, that is the degree of freedom for this test. And then similar to F-test, this one is always positive. So if there is a critical value somewhere, and then inside do not reject, outside reject, like this. So example data here. So H1 null hypothesis, location of the disclaimer is the independent of the nationality of the website. So test is like variable A affect variable B. Location of the disclaimer is not independent of the nationality of the website. After the test, if reject null hypothesis, then variable A and B, there is a relationship. Do not reject the null hypothesis, then they are not dependent. They are independent. There is no relationship. For this test, chi-square test, I'm going to use pH stat. Earlier when we did hypothesis test, then we used this pH stat. So I will bring up the data. So example, yeah. This data. So nationality of the website, and then disclaimer, location of disclaimer, contingency table. If we don't have a pH stat, then you can get that pH stat when we did hypothesis test. I uploaded the pH stat here. Because I changed my computer and then a new computer, so I don't have a pH stat. So I will add in pH stat. So first download the pH stat program, and then save somewhere, and then options, add in, and then go. Then if you have a pH stat, then pH stat here, and then it's supposed to be checked, but mine is not yet. So find the pH stat somewhere, wherever you download it. So click this one, and then OK. Yes. So I have a pH stat here, and then I'll click OK. Here I have a pH stat up there. Menu, click this one. And then this chi-square test is a multiple sample test. So click multiple sample test, and then chi-square test. Click this one. Then this one asks significance level. So 1.05. And the number of row. So number of row is 1, 2, 3, 4. Type 4. And number of column 1, 2, 3. Click 3. And then if we want title, then type whatever name, then click OK. Then this one gives you table like this. So go back to that data, then copy data, Control C, and go back to that table, and then just paste. Then this one gave you result. So the result, test result is reject the null hypothesis. Test statistic is 17.54, and critical value is 12.59. Because test statistic is greater than critical value, so test result is reject the null hypothesis. So reject the null hypothesis means, go back to data. Nationality of the website and then location of the disclaimer, they have relationship, so affect each other. So like the age group, and then the disease group. If you can, then using a chi-square, and then make a table, and then test. Then if the test result is reject the null hypothesis, then age and disease group dependent each other, so affect each other like that. Okay, any question? Okay, next. Practice problem again. A web-based anonymous survey of a student asked for self-rating on proficiency in language other than English. and the student frequency of newspaper reading. So there are two variables, like frequency of newspaper reading and then proficiency of language other than English. Then test at alpha equals 0.1 is the frequency of newspaper reading independent of foreign language proficiency. So data set is practice. So using a chi-square multiple sample test, chi-square test. Then alpha is 0.1. What the? Something wrong. 0.1. And then number of the row is 4. And then number of column is 3. Then okay, this one give you a table. And go back to data and then copy. And test the result. Do not reject the null hypothesis because critical value is now 10.64. Test statistic is now 4.14. So test statistic is less than critical value. So inside, do not reject the null hypothesis. So conclusion is daily newspaper reading, frequency of daily newspaper reading, and the other language fluency, there is no relationship. So I made an answer like this. So H0 English proficiency variable is independent of the daily newspaper reading variable. Actually, this one is other language proficiency, and then not independent. And alpha is 0.1. Based on output, 4.14 test the statistic, and critical value is 10.645. So decision is do not reject the null hypothesis. So conclusion is dependent variable 1 is independent of the variable 2, or you can say English other than English proficiency doesn't make a difference in newspaper reading like this. So this is a chi-square test. Looks like this. Okay, that's all for today's lecture. Okay, any question? Sorry again. Always when I give you assignment, feel sorry. Okay, so today's There is an assignment from this chapter. Just to try. If you can use the like megastat and pH stat, try. If you cannot use, then let me know. Okay. Okay. Any question?
Nope.
Okay. If you have a question or something, then stay. If you don't, then see you next Monday.
See you, Dr. Kim. Have a good night.
Okay, thank you. Bye.
Have a good night, Dr. Kim.
Thank you.
Thank you, Dr. Kim. Good night.
Thank you. Good night.